So when we're factoring polynomials, there's a lot to consider. The first thing we need to figure out is if these patterns are in play. And for a problem like this, we can see that I don't really have x cubes, but these both have x squareds or x's in them, so I don't know what's going to happen if I'm going to use these or not, but I do know I'm going to kick this off with the greatest common factor, because at the very least, like I said, they both have at least an x squared. As I look at it closer, I see that both these numbers also are even. So the GCF, the greatest common factor, could be a 2 and an x squared. And to figure out what's left inside, I would kind of ask myself, what would I multiply 2x squared by to get this back? And if I wanted to get back to 2x to the fourth, I would need an x squared inside, because 2x squared times x squared is 2x to the fourth. If I want to get negative 8x squared back, I would take this 2x squared and multiply it by just a negative 4. And you can see if you take 2x squared times negative 4, it is negative 8x squared. So you might think that you're done here, but this is a situation where we're going to have a perfect square and a perfect square subtracted by a minus sign, and we're trying to get you guys to kind of notice that as soon as you see it as something that goes further. X squared minus 4 breaks up into two things that multiply to make x squared, two things that multiply to make negative 4, and the inner and outer should make nothing. So we'll use a plus and a minus. And of course this 2x squared is still chilling out in front. So this is our final answer for the factored form of this expression. So this answer up here is a good answer, but the best answer for full credit would be the one where you actually take this difference of squares that's going to pop up a lot on this test and take it a little bit further. Good luck.